Greetings, detectives. Mrs. McKay here, and we're continuing on in case 4, which is all about growth patterns and how they change. So today we're going to talk about rate of change, and our learning target clue is I can identify the rate, so go ahead and write that here, rate of change in a linear function as equal differences over equal intervals. All right? And we'll talk about that a little bit more, but just so you know, an interval is a period of time, or it doesn't have to be a time, but an interval is another way of saying an equal movement over, so an interval is sort of a movement. So when we were doing arithmetic sequences, we went from term 1 to term 2 to term 3 to term 4. That's an interval. That's a change from one to the next. It was an equal interval because it was just a movement of 1. So you'll see what I mean when I talk more as we move forward, but just so you understand what an interval is. And then we want to make sure that we review and understand two terms: constant difference. Constant difference was a term we used. It's also sometimes called common difference. We used when we talked about arithmetic sequences. And in an arithmetic sequence, if we had the sequence 3, 7, 11, 15, you would say, oh, that's an arithmetic sequence because it has a constant difference of 4. We add 4 each time. So constant difference is that number that we add to a term to get the next term. All right? And then slope, that's just going back to what we were doing when we were graphing lines. Slope is the change in the change in y over the change in x. That little triangle means change. We also call it rise over run. And we'll see how that connects to our lesson today. All right? So, one last thing about slope. When we have slope-intercept form, y equals mx plus b, the m represents the slope. And the m is always a constant in a linear equation. Okay? All right, let's go ahead now and get started and talk about what do we know about our old friends, linear functions, because we've actually been doing a lot with linear functions. We call them linear equations, but they're functions, and they can be written like this. F of x, which we often say is y, it's the same thing, it's the output, it's the value, equals, and then we'll have, if we did it in slope-intercept form, it would be mx plus b, okay? So don't let the f of x scare you or make you think that this is something different. F of x just means the value, whatever this is equal to, that's f of x, all right? The function of x. When we put x into here, when we say f of 3, it means we put 3 in for x, okay? It's kind of like if you remember those little that little function machine that we talked about. You put something in, right? You put the x in, and you get the function of x comes out. And whatever your rule is, x plus 2, f of x is whatever x is, we add 2 to it, and that's what we get, f of x. So we put 2 in for x, we add 2, and f of x is 4. Okay, so don't let the function notation scare you. It doesn't mean multiplication, it means the function of x, or the value. The value of x when we do the rule or the equation, okay? So what do we know about linear functions? Well, we know that a linear function has two variables. So that means usually it's an x and a y. But it doesn't have to be x and y. It can be s and r. It can be whatever you want it to be. But usually it's x and y, especially when we're graphing a line, okay? So x, I'm going to make that say and. Let's see. I don't want that to be x plus y because that's not what I mean. X and y or r and s, just two of them, okay? So we know that there are two variables. If there's more than two variables, then there's a problem. Now you might think, Mrs. McKay, you just told us that y equals mx plus b is a linear function and it has 1, 2, 3, 4 variables, but it really doesn't because the m represents a constant and so does the b. When I write a linear function, I'll write it like this, y equals 2x minus 4. And notice that the m is now replaced with a constant and the b is replaced with a negative 4. It's the y and the x that are the variables that change, okay? So there are two variables. There are no exponents or powers. Notice when we write our equation, whether it's in y equals mx plus b or even in a standard form, 3x plus 2y equals 4, there are no exponents or powers. So you're never going to see this. Never, ever, ever are you going to see that in a linear function. You're not going to see a power. Okay, so we're going to draw a little circle around this and say no, okay? No exponents, no powers, all right? Now, the other thing that we know about linear equations or linear functions is that when we graph them, if we plot the points for x and y, we end up with a line. If we plot the points, it's always going to be a line. I'm going to draw my line this way. Okay? So we always get a line when we take a value for x. When we were up here with our function, if we had a bunch of values for x and we plugged them in and we got an f of x or a y, when we plot all those points and we connect them, we make a line. Okay, so that's another thing. When graphed, they make a line. Okay, linear functions can be in many different forms. We've got the standard form, which is ax plus by equals c. That's our standard form, okay? A is a constant, b is a constant, c is a constant, okay? We have our slope-intercept form, which is y equals mx plus b. We actually have another form that you haven't learned yet. You might have learned it last year, called point-slope form, which basically says that y1 minus y2, if we were looking at two different points, the first y of the point and the second y of the point is equal, when we take the difference of them, is equal to the slope times x1 minus x2. And actually, it might be the other way around. It might be x2 minus x1, but I don't think it really makes a difference, okay? And then we also have recursive, which is what we learned with arithmetic sequences, where we can say, and we're going to write it like this. f of 1, meaning the first term, equals a1, or the first term, okay? And then we say f of n equals the previous term, f of n minus 1, plus the constant difference. And we're going to find out that that constant difference is very similar to our slope, okay? So there are many different ways that we can represent a linear function, okay? And finally, the one thing about about linear functions is that they have a constant rate of change, and we've often called it the slope, okay? It's the constant rate of change. It's how we get from one term to the next term, all right? So let's look at an example that we did in class. We'll say this is x, we'll say this is f of x, or we could also say it's y, either way. But we had something like this. We had negative 30, we had negative 57, we had when x is negative 25, f of x is negative 47. Make sure that looks like a 25. When we had negative 20, when x was 20, f of x was negative 37. When x was negative 15, f of x was negative 27. And you see what we're doing, right? So there's a constant rate of change, and the constant rate of change says that the f of x, okay, has a constant difference, okay? So here it was plus 10, and it always stays the same, plus 10, from one term to the next. But there's more to it. We have to say, if I go back up here to my learning target, it says equal differences over equal intervals. So that just basically means the difference from one term to the next term in the y category, or the f of x, if we put that over the intervals from the x terms, so this would be negative 30 to negative 25 is plus 5. And this is plus 5. And this is plus 5. Now the key with this is to notice that it's the difference over the interval. They kind of mean the same thing, don't they? The difference in the interval, it's kind of the same thing. The difference is, what did I get? What did I do from the first term to the next term? And how are the x's? What I should say is, what did I do from the value, the f of x value, to the next value? How did I get there? And what did I do to get from, what is the interval between my x's? So you can see that my interval is 5 and my difference is 10. So remember, it's the difference over the interval, okay? The difference over the interval. Well, doesn't that sound a lot like rise, whoops, we'll make this be run, rise over run, or the change in y over the change in x? Yeah, it all means the same thing. So we have this fancy term that we say, I can identify the rate of change in a linear function as equal differences over equal intervals. Well, that's exactly what we're doing. The rise is the change in y over the change in x, or what did we do from one value to the next value, from the f of x to the next f of x. So what we're looking at is the constant rate of change, and that is called, we call it slope in a linear equation when we're graphing it, but we can also call it equal differences over equal intervals. All right? So now all we need to do is just do a little practice with that and make sure. We need to be able to use what we know about linear functions and decide if something is a linear function or not. And the main thing that we're going to use to decide is whether or not it has a constant rate of change. Okay? Whether it has a constant rate of change, which is equal differences over equal intervals. So we're going to do these problems over here on the side. Let's start with this very first one. Y equals 3x plus 4. What do you think? Is it a linear function? And if it is, what is the rate of change? What is the rate of change? Well, hopefully you immediately said, hey, that's y equals mx plus b format. So of course that is a linear function. Okay? And the rate of change is the slope, which is 3 or 3 over 1. Okay? So that one was pretty simple. Now, if you were unsure, you could have always plotted some points. You could have said, well, what if, let me see if I can find a place to do this. I'll do it down here. We said it was 3x plus 4. You could have done this. You could have actually created a table and looked to see if there were equal differences over equal intervals. So if I say that x is 0 and 1 and 2 and y, and I plug those in, when x is 0, then y is 4. When x is 1, y is 7. When x is 2, y is 10. And then I can look at my intervals and my differences. Here's plus 3, right? And my intervals are 1, plus 1, and plus 1. So my interval, my difference over my interval is 3 over 1, which is 3. Okay? So even if you can't recognize the slope-intercept form, you can do a table and look for equal differences over equal intervals. All right, let's do the next one. Y equals 3x squared plus 4. Is that a linear function? And if it is, what is the rate of change? This time, I hope you remembered right here where it says there are no exponents or powers, x squared is not allowed, so this is it is not a function. Not a linear function. It is a function, it's not a linear function, okay? Let's go on to the next one. Y equals x. Y equals x. Is that a linear function? And if it is, what is the rate of change? Well, this one might have confused you, so let's just take a look at it real quickly. Y equals x. Y equals x. If I did a little table, x and y, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. Well, what's the difference here? Plus 1, plus 1. What's the difference here? Plus 1, plus 1. What's the rate of change? 1 over 1 or 1. So, yes, this is a function, a linear function. And the rate of change is 1. Okay? If we actually graphed this, we would say, if you wanted to put this in slope-intercept form, it would be y equals 1x plus 0. Our y-intercept is 0. Our slope is, so we start at 0, 0. Makes sense, since 0, 0 is a point in the line down here, 0, 0. And then I would go up 1 over 1, up 1 over 1, up 1 over 1, and I'd have a line. Okay? Now try this one. F of 1 equals 3. F of n equals f of n minus 1 plus 6. Decide if that's a linear function or not, and if it is, what is the constant rate of change? Well, this one might have tricked you up a little bit because this is a recursive formula, but we can do the same thing that we've done before. Maybe I'll just do it right here. I'll say n and f of n, okay? So, n, the first term, when n is 1, f of n is 3. F of 1, meaning the first term, is 3, okay? And then the rest of them we can figure out. F of n, so whatever f of n is, it's going to be, so if I said f of 2, the second term, then that's going to be equal to the n minus 1, which is 2 minus 1. So that would be the first term, which I know what the first term is, 3, plus 6. So I just add 6 to the 3, and I get 9. So then f of 3, the next term, would be add 9 again, add 6 again to the 9, and this time I get 15. And 4 would be add 6 to the 15, and I get 21. So what's my equal difference if it is? Well, it's 6, right? I'm adding 6 each time. And my intervals are 1. My intervals are 1. So, yes, that is a linear function, and the constant rate of change is 6 over 1. All right? That one might have been a little tricky, especially if you're not remembering recursive formulas. Let's do this next one. X, there I have a table this time. X, f of x, when x is negative 10, f of x is 7. When x is negative 5, f of x is 7. What do you think? Is this a linear function? And if so, what is the constant rate of change? This one also might have tripped you up because the 7 didn't change, right? 0, 0, 0, 0. Here it did change. 5, 5, 5, 5. So our rate of change is the interval over the difference over the interval. So 0 over 5. Well, that's just equal to 0, right? 5 divided into 0 is 0. Now, if it was 5 over 0, that would be a problem because we can't divide by 0. But in this situation, we can. So, yes, this is a linear function. It just happens to be a straight line that looks like this. Slope of 0, okay? Slope of 0. All right, last one. This one, take a look at this one and see if you can decide if it's a linear function or, and if it is, what the constant rate of change is. This one was very tricky, and the first time I did it, I got messed up because I started saying, well, negative 5 to negative 2 is positive 3, right? Negative 2 to negative 8 is negative 6. Huh, that's weird. Negative 8 to 1 is 9. And 1 to negative 11 is negative 12. Well, those aren't the same. Those differences aren't the same. So that got me all messed up because I was like, that doesn't make sense. How can I go 3, negative 6, 9, negative 12? And then I went over to the x's and I looked at the intervals and I went from 0 to 4 is a 4. And from 4 to negative 4 is a negative 8. And from negative 4 to 8 is 12. And from 8 to negative 8 is negative 16. Well, now I'm really confused. What's going on? But then I remembered. What is my constant rate of change? It is the difference over the interval, right? The difference over the interval. So my difference is 3 over my interval is 4, 3/4. My difference is negative 6 over my interval, which happens to be negative 8, which becomes 3/4. And my difference on this next one is 9 over 12, which becomes 3/4. And the last one is negative 12 over negative 16, which is reduced to 3/4. So I do have a constant rate of change. It's 3/4. Well, why was it all wacky? Well, let's take a look. Look at my x's. They go 0, 4, negative 4, 8, negative 8. What if I put those in order? What if I put those in numerical order? And it was negative 4, 0, negative 8, negative 4, 0, 4, 8. And that would then mean that negative 8 would have negative 11 up here. Negative 4 would have negative 8 right here. 0 would have negative 5. 4 would have negative 2. And 8 would have 1. Now is it all nice and neat and tidy? Well, let's look. Negative 11 to negative 8 is 3. Negative 8 to negative 5 is 3. Negative 5 to negative 2 is 3. 2 to negative 1 is 3. Negative 8 to negative 4 is 4. Negative 4 to 0 is 4. Do you see what we found? The only problem that we had was that our numbers were out of order. So that's why it's important to not just count on looking at the differences and the intervals and seeing if they're the same, but actually putting the difference over the interval for each one and making sure that it's the same. And it is. So yes, this one is a linear function, and the constant rate of change is 3/4. All right, that's it for constant rate of change. Remember, you can identify the rate of change in a linear function as equal differences over equal intervals, meaning we take the difference over the interval, and each time they'll be equal. Now it's time for you to write a key idea, write a main idea. What's going to help you remember this? What is something that you don't want to forget about this? Write it here under the key ideas, and I will see you in class.